Okay, hi everybody. So as you can tell, I'm not at school today. Sadie's sick, so I'm at home taking care of her. She's got a little fever, so hopefully she's getting better. I just want to let you know I'm going to be checking a couple things right off the bat because I know a lot of people just listen to the first part and then skip forward. I'm going to check a couple things when I'm back tomorrow. First thing that I'm going to check is the homework that is due today. Now, I will see slides 3 and 4 there. I am going to go through the answers for the homework. So there's another opportunity for you to, get some free points there. But I just want to make sure you do this. This is a really important homework assignment. And, at least if you're just writing down the answers, I think something's soaking in there. So I'll go through this. And if you didn't do it, or if you did it, check your answers. And as we go through, if you didn't do it, I want you copying down all the work so I can see it tomorrow. The second thing that I'm going to check is I've got a warm up here and then 2 notes problems. Okay. I want you to do this warm up just as if we were in class. Okay. So take a minute right now, pause the video, and do these 3 warm up problems. Okay, so hopefully you paused and completed these 3 problems. Okay, so let's talk about 33 and 35 here. Let me move these down. It says, tell whether each equation is a direct variation. If so, identify the constant of variation. So remember what we talked about. A direct variation is in the form y is equal to k times x, where k is just any number. It could be y is equal to 4x, y is equal to 7x, y is equal to 10x, y is equal to negative 6x. That is a direct variation. Notice that there's no addition or subtraction. It's not like it's a y equals kx plus 10 or y equals kx minus 5. There's no plus or minus sitting out here on the end. And this is when y is completely solved for, okay? So y is solved for. I've got a y is equal to negative 6 times x, multiplication in there, right? So that means this k value is negative 6. K is negative 6. So we would say, yes, it is a direct variation. And then the k value is negative 6. Okay. Number 35 here. Notice that y is not solved for. So to get the y completely alone, I want to subtract the 4x over to the other side. Subtract 4x from each side. We get y is equal to negative 4x and then plus 3. So notice that I've got a plus 3 sitting out here. This plus 3 makes it not a direct variation. Well, that's bad T there. Not a direct variation. Okay. So remember that I can't have any plus or minuses sitting out here. Can't have any plus or minuses. So since it's not a direct variation, I don't have to identify the constant of variation. Another thing that we learned on Thursday/Friday is that k is equal to y divided by x, right? K is equal to y divided by x. So if I give you an ordered pair like this one here, I know that I can take k is negative 8 divided by 2, y over x. So this ends up being negative 4. So my k value is negative 4. And again, the reason why I'm giving you these blanks like this is because that's how I'll give it to you on the quiz. So make sure that, and I think I have it still written up on the board, the test is going to be on Thursday of this week. So I'm giving you answer blanks like I'm going to show you on the test. So my y is equal to negative 4x. That's my equation. And then it says, okay, if that's your equation, find y when x equals 3. So y is equal to negative 4 times 3, so negative 12. My answer is negative 12. Okay, so hopefully you got those right. Take out your homework and let's go through some of your homework problems. Okay, so let's go through some answers here. Again, you should be correcting your answers as you go with your homework. Okay, so this plus 9, yeah, that plus 9, y equals 4x plus 9 means not a direct variation, okay? Number 3, y is not solved for, so I got to divide by 2. So y is equal to negative 4 times x. This is a direct variation, right? No plus or minuses. So we would say direct variation, and then the k value is negative 4. Again, y is not solved here in number 4, so I've got to subtract x over to the other side. That means y is equal to negative x. Well, that's a direct variation, no pluses or minuses. So we would say our k value is, well, what's multiplied to x? A negative, so negative 1. So we would say that one is a direct variation as well. Number 5, see whether the relationship is a direct variation. For these ones, I'm going to add a new row down here on the bottom, and I'm going to make that my k row because it should have a constant k value. Remember what is k value? K is y over x. Okay, so if I have a constant k value for each one of these, well, that must mean that it's going to be a direct variation. So here's what I'm going to do. I'm going to take 12 divided by 10, y divided by x, 1.2. I'm going to take 7 divided by 5, 1.4. I don't even need to do this, but 4 divided by 2 is 2. The reason I don't need to do that is because I have different k values. So we would say not a direct variation. Number 6 here. Again, this is my k row. Negative 6 divided by 3 is a negative 2. 2 divided by negative 1 is a negative 2. 8 divided by negative 4 is a negative 2. This is a direct variation. Okay? It doesn't tell us doesn't say you need to find the k value, write the equation or anything, but we could. Look, the k value is negative 2, so we could say y is equal to negative 2x. All right. Number 7. 7 and 8 are both like one of these problems. So the value of y varies directly with x. So y is equal to k times x, which means that k is equal to y divided by x, which is negative 3 divided by 1, y divided by x. So, excuse me, that means that my k value is negative 3. My equation is y is equal to negative 3 times x. And then when I plug that in, y is equal to positive 18. Okay. Plug in negative 6 into that equation, I get negative 3 times negative 6 is positive 18. So here's number 8. So k, again, is equal to y divided by x. And in this case, y is 6 when x is 18. So reduce that fraction down, I get 1/3. So y is equal to 1/3 x. Plug 12 in, 1/3 of 12 is 4. Okay, let's keep it rolling. So just kind of starting over with these problems. So is that a direct variation? Yeah, that is a direct variation. K is 1/6. No addition or subtraction signs. This, well, I don't know yet. Y is not alone. Divide by 4. So y is equal to what was in front of x? 1 was in front of x. 1/4 x. So yes, it is, with k value being 1/4. It is a direct variation. This one here, y is not solved for. So I'm just going to add the 12 over to the other side. I get x plus 12 is equal to 2y. I divide by 2 to everything. So 1/2 x plus 6 is equal to y. And look, plus 6. That plus 6 means not a direct variation. Okay. Moving on down. Got to make a new row for my k value here. Okay, so my k value goes right here. So let's check. I've got 13.2 divided by 6, y divided by x is 2.2. I've got 19.8 divided by 9. Hey, look at that, I got 2.2. Let's hope that 37.4 divided by 17, 2.2. Is this a direct variation? Yes, I do have a constant. My k value here, 4 divided by negative 6, 4 divided by 6, well, negative 0.6. Negative 2 divided by 3, negative 0.6. And then 8 divided by 12. 8 divided by 12. 0.6. Yes, direct variation. Number 15. K is equal to y divided by x, which is 8 over negative 32. So that gets us, well, 8 over 32 is 4 over 16, or 2 over 8, or 1/4. So negative 1/4. So y is equal to negative 1/4 x. And then I plug that back in. I take 64 by 4. I get 16. Oh, that should have been a negative. Negative 16. Negative 1/4 times 64. And the last one here, number 16. K is equal to y divided by x. Okay, now this is a weird one because I've got 1/2 divided by 3. Right? 1/2 divided by 3. Remember that if I have a fraction, I'm dividing by a whole number. It's really like multiplying by the reciprocal. So 1/2 times 1/3 would be 1/6. So y is equal to 1/6 x. So if I plug in 1, I get 1/6 again. That's a weird one. All right. So notice that for today's notes, again, I want to see the warm-up and then today's notes. Okay. Now, obviously, I've only got 2 slides, so it's only a couple problems, but it's just an extension on direct variation. Okay. So let's see what else I got here. A group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that people will float in X hours, then graph. Okay, so what I'm looking at here, I think I mentioned it to you guys on Friday or Thursday or whenever that was, that, because my equation is y is equal to k times x, that k value ends up being my slope because k, again, is y divided by x. Change in y divided by change in x, that is my k value. Now, if I'm thinking about these people tubing down the river, the average speed is their average rate of change. So rate of change is the same thing as slope is the same thing as our k value for direct variations. So what I'm getting at here is if I've got this 2 miles per hour rate of change, that I know that's actually just my k value. Y is equal to 2x. There's my equation. Okay, so that's not too bad. Let's graph it now. Let's say here's my axes here. Ooh, wiggly line. Yikes. I'm very good with my stylus there. Okay. Now, so this is, what's my x value? My x value is time, and my y value is miles. So time in hours, and then the y value is miles. Okay, so at 0 time, if I plug in 0 into this equation, I get 0. So at time 0, I'm at miles 0. If I plug in 1 into this equation, I'm at 2. 1 comma 2 miles. If I plug in 2, I get 4. If I plug in 3, I get 6. And so on, right? Remember that I'm not picking which domain to use, so I could pick anything in there. Okay, so there's my line. Okay, good. All right, now this last one here, this last example. Each ordered pair is a solution of a direct variation. So I'm telling you right away, that is a direct variation. It's a point that hits that direct variation line. Write the equation of the direct variation, then graph your equation and show that the slope of the line is equal to the constant of variation. Okay, so here's what I want you to do. Remember that the constant of variation, the k value, is just y divided by x. So I can find my constant of variation really easily right here. -9 divided by 3. Well, that's just -3. Okay? Now I need to graph this function. Here's the cool thing. Y is equal to kx. I don't even need to know what coordinate this is running through. If I plug in 0 for x, what do I get for y? No matter what k is, if I plug in 0 for x, k times 0 has to be 0. Y equals 0. So every direct variation, no matter what the k value is, if I tell you if it's a direct variation, if I plug in 0 into my direct variation equation, I have to get out 0. Every direct variation must go through 0, 0. So the cool thing about this is if I give you a point and say, okay, that runs through direct variation, all you need to do is graph 0, 0, and then that coordinate, 3, 9. So let me scroll down just a hair. So 3, -9, there's that point. So here is my direct variation. Now I'm going to be fancy and get a line tool here. Let's use arrows, sure. Okay, there's my direct variation. It must run through 0, 0. It must go through that point, and we know, we've talked about it, we only need 2 points to make a line. So my equation, so there's my graph. Got to kind of have to follow directions here. Write the equation of the direct variation. Y is equal to -3 for our k value, x. Here's our equation. Graph your equation. Now, the last thing that we have to do is show that the slope of the line is equal to the constant of variation. So I'm just going to take another pen here, and I'm going to go into my graph and say, okay, is the slope really -3? Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Yeah. So I'm showing here that I'm going down 3, right 1. Down 3, right 1. Down 3, right 1. I'm showing that the slope is the same as the constant of variation. Okay. I want you to pause and do it with this one. Try to do the whole process that we did. Okay, so the first thing that I did was I found my k value. K value is y divided by x. Okay, -2/5. So my equation is y is equal to -2/5 x. We know that it must go through point 0, 0, and I tell you that it's going through point -5, 2. So there is my line. Get my line tool again. Ooh. Come on now. Okay, there we go. It's going to run through those points just like that. Okay, now the last thing I have to do is show that the slope is the same as the k value. So my k value is -2. That means I need to go down to, whoa, right 5. Good. And then we'll go down to right 5 to that point right there, down to right 5. So I'm showing here that the slope is the same as my constant of variation, my k value. Okay. All right, I hope we're all having a good day. Again, remember that the two things that I'm going to check. I'm going to check the homework assignment that we went over before, and I'm going to check the warm-up with these notes. Okay. Now, the sub should have a worksheet for you. I'm going to put in my sub plans to make sure that you guys have all of the notes written out before you get the worksheet. So you have to show her the notes before you get the worksheet. Okay. So I hope everybody's having a good day, and I'll see you all tomorrow.